I asked you, I said, right, we've got, what's it, 1, 2 small blocks. If we add that to one of the longer bars and then add that to one of the bigger. So, without telling me the arcs, so Ryan, he's in the house off now. What's the process? What did you go about doing?
Well, so you have to first measure out these.
Okay.
And as you can see, one.
When you say these, so you want to know how many of these bars
So
fit
we
in here.
already know that the 2 is 6.
Okay, so the bar is 6 small ones, yeah?
Yeah.
So these are ones, this is a 6.
This goes in this.
How many of the bars did you think fit?
I thought that 5 of them. So.
What do you think? Is that everyone?
5 and a half. 5 and a half or 6 if you don't want to be exact.
Okay, well, I tell you what, I'll go. I'm happy if you are all just picking on the half. I'm happy to say that that is 5 bars. So do we have to go any further than that? Well, we'll stick with the 6. We did that. We already discussed. You said it's 5 and a half, but yeah. Well, that will change your numbers, but it won't change your method. So what's the method? Yeah. Yeah. So we'll agree, even if you don't agree, that we're fitting in 5 bars, right? 5 bars. Yeah, we'll agree if we did agree. Yeah.
Basically you convert, so there's you're saying this the body is 6. So
Okay, so that's 5 bars. So this is 5 lots of 6. So 30. If it's halved, mate. If it's just like 5, if it's 6, then we've got 5 lots of 6. Does that make sense to everyone? So we've got our units, we've got 2 of them. The bar is 6 units, so that's 6. 1 square is 5 bars, but each bar is 6, so we've had to say that's 5 lots of 6, which is 30. So if we add all that together, we get 38. So we think this, adding all this gives me 38 what? Units. Small squares, yeah? What have you got? Unit squares, whatever. They're not cubes. Because they're not 2-dimensional. Alright, okay. Hopefully then, you'll see where we're going. So, because we're now, like, the building phase is seeping into around everyone, so guys, thinking about this process, I think you should have your maths books out now. Don't keep it waiting longer. Come on, Ryan. Come on, get both open. Maybe work writing this down. Alright. Thinking about this process where we looked at, we can't add single squares to bars to a big square, we have to do something first. So, let's just check. Using that process, we can always come back to that if you want to write it, but that was your thinking part. So if I said to you, we've got 1/5 plus 2/5, what's the answer? And then if I said, don't tell me yet, just write them down, right? If I said we've got 1/3 plus 1/2, what's the answer? And to extend anyone further that thinks they know the answer straight away, we do 1/4 plus 3/5 plus 5/6. Okay? That's the fun if you're kind of really confident. So your focus is on those 2, and if you know you're really good at it, you can do these. So my clue is what you've just been doing. Right? A fraction is a description of a thing, right? It's not just random numbers written with a line in between on the paper, right? It's a description of part of a thing. you were telling me what a numerator means, what a denominator means. All right? So what does 1/5 mean? Emma? Yeah. You've got one part of something that you've chopped into 5 parts, yeah? All right? So think of it that way. So think what would happen if you take those things and add them together. How would you be able to describe it? So the first one, and then this one, that's like the second part that we did. That's like adding small squares with bars. Alright? So you can't just chop those together. You've got to do something else. Right? It makes sense to just clump them together. And in your head, you'll know that. But because it's just numbers, you'll just come with a solution and just to get around it. You'll probably end up with an incorrect answer. Okay? So you're going to try and apply what you've just been doing to answer those. So, have a think about it. Maybe if I do the first one, it will help you go, oh, okay. So, 1/5, can you say it with me? 1/5 added to 2/5 gives me, so why do we write 3/10?
We don't.
You are correct in what you said. 1/5 plus 2/5 gives me 3. I wasn't looking at you. People around. 3/5. And it's funny, when you actually say it to yourself, instead of thinking of it, because those that did 3/10 didn't think of it as 1/5 and 2/5. They thought of it as 1 and 2 and 5 and 5. But they're not. Right? It's not. This is not a 5. It's how many fifths. It's a number of fifths, right? It's not 5, it's not 1. Right? So we can't add them together. So we've got 3/5. Now, if we're not allowed to add those together, so it's not 3/10, that doesn't make sense, does it really? You don't know? It doesn't when you think about it. Right, it obviously, here, I'm going to know straight away, what's the answer not? 2/5. Yes, definitely not 2/5. Alright? If you don't mind, Karen, because I know you know it, so it'd be good if I can try and get this out of everyone else. I know you're good with it, so. Right? If you're done, if you finish that third. No, not quite. You carry on working through that. Carry on working. You'll find it. Alright, so this one, guys, it's like the squares and the bars. Alright? I've actually given you quite a harder one. It's not quite as easy as the squares and the bars. Alright? But we do know we need to find a way to compare them so that they're the same size. Alright? Now, which number in the fraction tells me the size of the fraction? Okay? Kristen? The denominator. The 3 and the 2. Right? Which fraction is bigger, Jackson? Which is the bigger fraction? The half, yeah? Right? You got that? So we know half is bigger than a third. So you can't add them together. They're different sizes. But we can write them as equivalent fractions so that they have the same denominator. Any ideas what that could be? How did you come up with that? Okay. So I think he's decided we need to make, do you remember we did before that if you take a fraction and you chop it up into smaller pieces, you've got smaller pieces but you've got more of them, so it means the same thing, huh? So what Zari's saying is, this one could be, right, if I write it above different colour, if I can get that. Right, 1/3, if I chop that up into sixths instead, how many pieces? So instead of 3, there are now 6 pieces. So where there was 1 from 3, there'll be now how many? 2. because we multiplied by 2, and we get 2 sixths. So let's add that. Well, this one as well, we can make it 6 pieces too. But what do I need to do to it? Times it by 3, this one. So if I've got 6 pieces there, how many have I got out of those 6? 1 from 2 means I've got...
Why do you have to put 2 on the first one?
Because 3 times 2 is 6.
Yeah, I need to make it 6 pieces, yeah? Everybody is the same. But if I've got 6 now, 1 from 2 means I've now got how many from 6? 3. So I also multiply by 3. Okay. So are you all happy that both of these fractions are the same as they were, just using different numbers? Yeah? Can I now add them together? Yeah, good. So it's 5, 6. Well done. That's the answer. Okay. All right. Before we move on to this one, because this was the challenge one, let me give you another one with just a couple, and you can follow that, yeah? So this one, I know Kieran's still working away, he's trying to find... It's the same thing, but we'll talk about it in a second. Have you written that down, everyone? Okay? Keen, give me a fraction. 2/3. Georgia, give me a fraction. 2/5. It's not my fault. Those two did it. Simone, give me a fraction.
5/8.
Max.
1/2.
Max is nice.
And
That do for now?
one more.
I've just not got space, otherwise I definitely would. I'll give you another one in a second.
Why 3 and 4?
If you're desperate, yeah, we've only got like 10 past 10. We've got 10 minutes. You can go. Let's have a quick look then. Right, ladies and gents. Masks, just saying. Picking names. Right, I'll come back to this one if you like, because a lot of you are challenging yourself. Alright, so we did mention it, but this process that we did up here, where we found this number, Zoe told us that, well, hopefully you'll recognise that 6 is the LCM of 2 and 3. Lowest common multiple. So we use the highest common factor when we're simplifying fractions. Now we're finding equivalent fractions to be able to add them and subtract them, right? We find the lowest common multiple. So in these questions, all right, we want to find the lowest common multiple of 3 and 5, which is 15. So I can rewrite it with what is the denominator, King? 15. All right, so all I have to do now is figure out, well, what do I do to 3 to get 15? Multiply by 5. What do I do to 5 to get to 15? Okay, so once you've got that sorted, the tops are easy, aren't they? Because what do I multiply this numerator by? 5. So that becomes?
10.
This one multiplies by?
3.
To become? We now add those together and get? 16 over 15. Right, can it simplify?
It can go to 1 and 1/15.
1 and 1/15 as a... Now that's not necessarily simpler, it's just an improper fraction. That's fine. Yeah? I don't want the answer to that long one just yet. I know, we'll do it in a sec. You can talk us through it. Okay. All right. Now, I did spot Ryan, who was saying yours because there was nothing wrong with it. Ryan went up to 30 for the common denominator. Absolutely fine. Not a problem at all. Right? But what do you have to do if you go up to, if you don't use the lowest common multiple, just a common multiple, what are you going to have to do at the end? Simplify. Yeah? But it's not a problem. And that's why the second one, although easy, could be a really good question to check your understanding. So, Keen, do you want to talk us through? What did you choose?
Well, can I just say the answer and then say how I got it? Or
No.
oh, okay. Well, so I did it a different way that I taught earlier. So I did 1 times 8.
This
So
one.
cross times 8, and then 5 times 2. Oh yeah, 5 times that way.
Yeah.
So you have on the top
10.
10 over 15, and then
Well, that's not a different way. I mean, that's maybe going through a slightly different order, but and then you get 18.
16.
Okay. So, I'm not going to say this because it's a bad thing. Right? Absolutely fine. Absolutely fine. All right. There is a kind of a process that people give you. It always works, which is this cross multiplication thing. You hear that again? Cross multiplication. Gets a bit kind of like everything you do with fractions ends up being cross multiplication. The only trouble with that is you always try and do it even when it's not supposed to. Right? So this one, he's multiplied like we were doing before, right? When we did the division. And he's ended up with exactly the right answer. But if you jump straight into that, there is something we've missed. Is there anything we could have done slightly differently? Des? We could simplify this, definitely. But I'm thinking, like, before, like, Keen's method was absolutely fine. He's multiplied, but there's something that he didn't need to do everything like that. Has anyone spotted it? Exactly that, yeah? Instead of relying on always doing multiplying by each other, we could spot that actually, I want the lowest common multiple. What is the lowest common multiple of 8 and 2? It's not 16. It's 8. The lowest common multiple of 8 and 2 is 8, because it's 8 times 1, so I don't need to do that, and it's 2 times, so actually I only need to change this second one, and it becomes 5 eighths plus 4 eighths, and the answer is 9 eighths. Now do you see that 8 sixteenths would, if I divide by 2, give me 9 eighths. So it's fine. But do you see how we can, if we find the lowest common multiple, we can keep things a bit simpler? Yeah? Does it all make sense?
Yeah.
All right. Question?
I wrote mine was 1 and 2 16.
Okay. So this would be 1 and 1 eighth as well, wouldn't it?
Yeah.
Which would be 1 and 2 sixteenths. But you could still simplify the 2 sixteenths to 1 eighth. All right. Just because I'm aware that I've literally got, well, the end of third is 5 minutes. Okay.
No, it's
So-
on the computer 2 minutes.
Yeah, the computer's wrong.
Oh.
It's like I fell for that before. All right. Right, guys. This one. How is everyone feeling about the ones you've just done? Okay. All right. What I'll do is, before I look at that one, I'm going to give you another one for everyone to do before we look at the long one. All right. Just one more. One more. Any comments? Any questions? Is it the same thing? Yes. Same thing. Only instead of adding, you subtract. I'm aware, well, I've got
It's still 10:05.
now just one, but it's only 10:05 and you're less than what we.
That's wrong on here. It's supposed to be
So that should be
10:05.
10:05. We've got 5 minutes. Okay, so I'm going to stop my recording. But